So in this particular section, we are going to discuss about different types of functions. So here I have stated 6 different types of functions. The list is not exhaustive. We have lots of different types of functions. However, these particular 6 functions are the ones that we will be encountering over and over again throughout this particular course. So let's start with the first function. So we have a polynomial function. So the simplest polynomial function we can think of is x. So this is a straight line that passes through the origin. Then we can have a polynomial function with a power of 2. So this is a parabolic function, and we can have combination of the linear function and the parabolic function. So x cubed, which by the way I need to mention here that this x is also referred to as a linear function. X squared will be a quadratic function or a parabolic function. So we can have a combination of x cubed plus 2x squared minus x. So such type of functions are referred to as polynomial functions, where the powers of x are positive integers. Then we have power function. So power function will be, so in the case of a polynomial function, so this is a power function. So we have, so here we are using the variable x, or we can have y as well, but for simplicity purpose we are going to consider only the variable x, which will be a single variable. Now here power function refers to the power or the exponent of x. So x squared, so this can be a power function x. The linear function is also a power function as well, so its power will be 1. The power or the exponent is not only limited to positive integers or natural numbers. We could have -3 as possible, so negative integers are also allowed here. So this is actually equivalent to 1 over x cubed. Then if we have square root of x, so this is also considered as a power function, because this can be also expressed as x raised to the power of 1/2. Then we have trigonometric functions. So these are the functions that involve trigonometric values such as sine of x, cosine squared x, or any complicated looking function to tangent of x plus secant x. So these are referred to as trigonometric function. Then we have rational functions. So rational functions are when we have a function of the sort, let's say x squared plus 1 divided by x cubed minus 2x. So this is a rational function. Rational functions are also referred to as ratios of polynomials. So here the numerator is a polynomial function, so is the denominator. So when we have one polynomial function divided by another function, so that is when we get a rational function. Then we have exponential function. So exponential function will be a e raised to the power of x. So this is an increasing exponential function. Then we can have decreasing exponential functions as well. We can also have some complicated looking exponential function, e raised to the power of x squared or e raised to the power of negative x squared. So let me consider plus or minus x squared. Then we have the logarithmic function. We'll consider the simplest one. So we have the natural log of x. So these are the different types of function, and we will be coming across each one of them, or sometimes it could be combination of any of the 6 functions in our course. So now let's talk about a few numerical problems based on whatever we have learned so far. So here we are provided with the function f of x equals to e raised to the power of x. Now we need to investigate the properties of this particular function. So let us begin. So f of x equals to e raised to the power of x. So this is also referred to as the exponential function. The shape of this particular function is going to look something like this sort. So this is an increasing exponential function. So it's going to start from a very low value of y, and then it's going to slowly increase, and it crosses the y-axis at a value of 1, and then it's going to keep on increasing. This is the illustration of an exponential function. But first we need to verify whether if this is actually a function or not, even though I've already mentioned that this is an exponential function. And in order to check whether if it is a function or not, all we have to do is perform the vertical line test. So what we'll do, we'll do vertical lines and we will check whether if this particular line intersects the curve at only one single point or not. So here is intersecting this particular exponential graph at a single point. So we can draw vertical lines at different values of x. So here also we see that this is intersecting the graph at a single point. So we will say that the exponential graph, this passes the vertical line test. So that would mean that it is a function. So our exponential function is indeed a function. Then number 2, let's talk about the domain of this particular function. So the domain will be for all the values of x for which we get a specific value in y. So here the domain will be defined as negative infinity to positive infinity, and the infinity values cannot be bounded, so we'll put it under parentheses. So this will be an open interval. So this is going to be domain means that x can take any values from negative infinity to positive infinity. Then we come to the next part, which is the range. So what will be the range of this particular exponential function? So range refers to all the y values that this particular function can have. So clearly from this illustration we can see that the y value does not exist in the negative y-axis. So its minimum value could be 0 and it can go all the way up to infinity. However, we have to be careful when we close the interval. Either should we use a closed interval or an open interval. So it depends. So for infinity there is no issue because it's always going to be on open interval. However, if we look at the lower limit or the lower value, so here we have 0. So here the exponential value or the exponential function actually never goes to 0. It will be as close as possible to 0. So this is going to be an open interval. Then next comes the question whether if it is increasing or a decreasing function. For that, all we have to do is we have to read the graph as we move from left to right direction. So we see that this particular function from the graph itself, it is increasing. So we can say that this is an increasing function. There is a mathematical way to check whether if this particular function is increasing or not. All we have to do is consider two x values on this graph. So for each x value, we have to find its corresponding y value. So this will be f of x1 and we have x2. So its corresponding y value will be f of x2. So the condition is that if x2 is greater than x1, and for this particular condition, if we are getting that f of x2 is also greater than f of x1, then we see that our function is increasing. So yeah, so this is what we have to check. So let's try out another problem. Problem number 2. So here we are provided with the logarithmic function. So we need to investigate the different properties of this function. So let us begin by sketching the graph of this function. So we have the y-axis and then we have the x-axis. Now what we can do, you can follow this website desmos.com. This is a graphing calculator. You can plug in the function ln x. So this will be the natural log of x, and this is going to give us the graph of the logarithmic function. So this is a function f of x is equals to natural log of x. Now let's talk about the first property. So first we need to check whether if this function is indeed a function or not. So all we have to do is we have to check if it passes the vertical line test. So we draw a vertical line and we see that this vertical line is going to intersect the graph of the logarithmic function at a single point. So that means it passes the vertical line test. So this implies that f of x is a function. Point number 2. So let's talk about the second property, that would be the domain of this particular logarithmic function. So from the definition of the logarithmic function, we know that log of x is only defined when we have the value of x which is greater than 0. That means x must be a positive number. It cannot be 0. It always has to be greater than 0 and it has to be positive. Only then we can define f of x. So this is going to be the domain. So if we want to express this in the interval form, so this will be simply, so it starts from 0 and goes all the way up to infinity. So infinity is unbounded, so we use the open interval and we have greater than 0. So 0 is not included, so this is going to be an open interval as well. Fine. Now coming to the range. So range is all the values of y. So here clearly we can see that from the graph it's quite evident that the logarithmic function can take any values both in the negative y-axis as well as the positive y-axis. So we'll say that its range is going to start from negative infinity and go all the way up to positive infinity, and this is going to be an open interval. Next, number 4, we'll check whether if it is an increasing or a decreasing function. So all we have to do is take 2 points x1 and x2 and find their corresponding values on the y-axis. So this will give us f of x1, and for x2 we'll have the corresponding value f of x2. So we say that since x2 is greater than x1, and this implies that the function f of x2 is also greater than f of x1. So here we can say our function f of x is increasing. And also when we look at the graph from left to right, we can see that our function is increasing. Our fx value is increasing. So this value, the height of the function is increasing as we move from left to right. Let's move on to the next function. So our function is given by f of x is equals to sine of x. So this is a trigonometric function. Most probably you would have encountered the sine function or the sinusoidal function in your pre-calc class, and the graph of this particular function is going to have the shape. Or if you have forgotten, you can always go to desmos.com and verify that this will be indeed the graph of a sinusoidal function. So this function is going to have a minimum value of -1 and it's going to have a maximum value of +1. So this is a graph of the sine x function. So the first thing first, so is it really a function? So we will perform the vertical line test. So here, yes. The vertical line intersects the graph at a single point. So anywhere we draw a vertical line is going to intersect the graph at a single point. So yes, we will say that f of x passes the vertical line test. This implies that f of x is a function. Now coming to the next property, so that will be the domain. So domain will be all the values of x for which sine of x is defined. So here we can say that x can take any value from -infinity to +infinity. So its domain will be -infinity to +infinity, and this will be an open interval. Then we have the range. So the range of a sinusoidal function, so it has a maximum value of 1 and a minimum value of -1. So it's always going to oscillate between these two extreme values. So we'll say that the range is going to be -1 to +1. Now this is going to be a closed interval because -1 and 1, both of them are included. And finally, coming to whether if it is an increasing function or a decreasing function. Now that's a little bit tricky. This function is actually increasing and decreasing, but also we need to specify from what particular values, for what particular values of x it is increasing and for what particular values of x it is decreasing. So if we look at this graph, so here we will see, so let's talk about the increasing portion first. So for this we need to have the x values here. So it starts from 0. So this will be pi. So it has a maximum value at pi over 2. So this will be 3 pi over 2. So this is 2 pi. So similarly we have negative pi over 2. This will be pi. We have negative 3 pi over 2. Negative 2 pi. So here we'll see from pi over 2 to positive 3 pi over 2. Here, clearly the graph of sine of x is decreasing, and if we consider from negative pi over 2 to positive pi over 2, so here it is increasing. So there's a particular range of values, range of x, for which these graph is increasing or decreasing. So let me specify it. So this is going to be increasing on, it's going to be increasing on the interval negative pi over 2 to positive pi over 2. Then again you can see from 3 pi over 2, so this will be 5 pi over 2. So this is 3 pi over 2 to 5 pi over 2. So these are the different values on which this function is going to be increasing, and it is going to be decreasing on the interval. So we have from positive pi over 2 to 3 pi over 2. It's also decreasing from negative 3 pi over 2 up to negative pi over 2. And there will be other different range of values. Fine. Let's move on to the next problem. So we have the function f of x is equals to cosine of x. So this is also a trigonometric function. Let's try to sketch the graph of this particular function. So we have our y-axis and we have our x-axis. The only difference between the sine function and the cosine function is that, so the cosine function is going to start with a value of 1 at the origin, and then it's going to decrease. So 0. At pi over 2, it's going to be 0, and then at pi, it's going to be as a minimum value of negative 1. Then again, it will start increasing. So at 3 pi over 2, again, it will be 0, and then it's going to increase and go to a maximum value of 1 at 2 pi. So this is a symmetric function, symmetric about the y-axis. So a cosine function is an even function. So the same story goes along the negative axis as well. So let's use the value. So this will be negative pi over 2. This will be negative pi. This will be negative 3 pi over 2. This will be negative 2 pi. So I'll write down the properties straight away. So this one passes the vertical line test, and therefore we can say f of x is a function. Number 2, f of x is an even function. So a cosine function is an even function because it follows that f of negative x is equals to positive f of x. Then number 3, we'll talk about the domain. So the domain, this will be similar to the sine function. So that will be from negative infinity to positive infinity. And number 4, so will be the range. So the cosine function also oscillates between negative 1 and positive 1. And this will be a closed interval. And so it is going to be increasing in the interval. So here we see from negative pi to 0, it is increasing. It's going upwards. So from negative pi to 0, so this is increasing. Then again, here also we see from pi to 2 pi, it is increasing. So there will be other range of values for which it will be increasing. Then we have decreasing. So we have from negative 2 pi to negative pi. So here it is decreasing. Then we can consider from 0 to pi. So here it is decreasing as well. Yeah, so this is how we can check out the different properties of a function if we have its graph, and you can always go to Desmos to verify the different shape of the graphs and check out if it passes the vertical line test or not.